So today first we are going to talk about a concept called automatic shared memory management. But well before that, once again I'm reminding you about the PGA component. So we already understood that PGA is the memory area that was allocated to server process, and some activities like execution etc will take place there. And whatever you are seeing on the screen, this is what PGA contains. So PGA was actually divided into so many memory areas, and also we discussed other point like before 9i, the size of the PGA is used to be defined by these four parameters. So work underscore area size, bitmap work area, etc. But from 9i onwards, we are going to define the PGA size with the help of a parameter called PGA underscore aggregate underscore target. So suppose if I give PGA underscore aggregate underscore target equals to 200 MB, and 10 users got connected to the database, that means this 200 MB will be shared across all the 10 users. So it will be totally of each user will be getting a total of 10 MB. Each user will be getting a total of 20 MB. So that is how the memory distribution from PGA will take place. And also I said that in 8i, when we define these four parameters, work area size, bitmap work area, etc., then we need to manage the memory, by reducing one memory size and by increasing one memory size and all. And whenever we want to do that, we require a shutdown of the database. And from 9a onwards, when you declare the PGA size with the help of this parameter, PGA aggregate target, then we don't require to do anything. Oracle has been automated the task. So from 9a onwards, the management of the memory or the adjustment of the memory inside PGA will be taken care by Oracle itself. So this is what we understood about PGA, and bringing the same concept again in 10G. So what happens in 9i, or what used to happen in 9i, is we use it to set the parameters separately or individually for different memory components. Like for shared pool, we have a parameter called shared underscore pool underscore size. For database buffer cache, we have database underscore db underscore cache underscore size. And for large pool, we have one parameter. For Java pool and all, we have one parameter. So in 9i, what we use it to do is, as a DBA, we use it to define that shared pool should have this much size, or database buffer cache should have this much size, or large pool log buffer cache, all these memory components should have this much size. So we use it to declare all these in the parameter file. But again, whatever the problem that 8i DBS faced with PGA, so similar problem has been faced by 9i DBS with SGA. So the problem is adjusting the memory. Suppose your shared pool is defined with 200 MB, but there is a PLSQL program that is getting executed, and let's say that requires more than 200 MB. So in such case, you need to decrease the size of database buffer cache, and then you need to increase the size of shared pool, or you may need to adjust between any two memory components. So this kind of adjustment is been a panic in 9i database. So that is the reason 10G got introduced with a option called automatic shared memory management, in which Oracle says whatever the size you want to allocate for SGA, just you can give that value, and automatically the memory adjustment will be taken care by Oracle itself. So that is what the basic concept of automatic shared memory management. By the name also we can understand the shared memory. Shared memory is nothing but SGA, is getting managed automatically by Oracle. And this concept we call it as ASMM, and this got introduced in 10G. So that is where first few points talks about. Like in 9A, the SGA has been made dynamic. That is, the sizes of SGA components can be changed without shutting down the database. But even then, many times DBS faces so many problems in calculating the correct memory size. So that's the reason 10G introduced with ASMM. And when you define this ASMM, then whatever the components that are listed in point number 3, so those components will be automatically adjusted. So shade pool, database buffer cache, large pool, Java pool, and stream pool. So these 5 components will be adjusted automatically with the memory. But log underscore buffer, this is the parameter to define the size of log buffer cache. This parameter will be always static. Even when you go for 11G also, this parameter is static. So that is the reason you cannot automatically size this any version. And how we are going to define this automatic shared memory management is with the help of a parameter that we need to declare in P file or SP file. So the parameter name is SGA underscore target. You can see over here. So for example, if I want SGA target or all the memory components together to give somewhere around 800 MB, so I need to I can just specify that with the help of the parameter. And next we have a note which says if at all we want to enable ASMM, then we need to define another parameter, that is statistics underscore level equals to either typical or all. So by default it will be typical. So that means by default in 10G ASMM will be enabled. And apart from specifying the SGA target size, we also have one more parameter like SGA underscore max underscore size. So actually what Oracle suggests is, suppose you want to give 800 MB to SGA. So what Oracle usually prefers is, don't give entire 800 MB to SGA at the same time. Rather, allocate somewhere like 550 MB or 500 MB to SGA and give SGA max size as 800 MB. So that means when you want to give the maximum value as 800, then you need to define your SGA max size as 800 and somewhere around 500 MB also you need to give for SGA target. So what happens during this time is, whenever you start your database, first Oracle will get 500 MB because you specified SGA target as 500 MB, and then depends on the load increasing. So number of users are connecting or number of transactions are increasing. In such case, Oracle will increase this 500 MB to 800 MB, that is the maximum size. And whenever the transaction load is coming down, again that 800 MB will come down to 500 MB. So this is what usually will happen in 10G database. And sometimes what you would be observing is, apart from this SGA target and SGA max size, even the individual parameters will also be set, and those individual parameters will act as the minimum values, then SGA target will act as the medium value, and then SGA max size will act as the maximum value. So if you have individual parameters, then SGA target, SGA max size, then it's like minimum, medium and maximum. But if you have only SGA target and SGA max size, it's like minimum and maximum. So there will be no medium values over there. And as I said, basically ASMM is to adjust the memory between several memory components inside SGA. So there is a new background process introduced, that is MMAN, stands for Memory Manager. So this background process is responsible for adjusting the memory between several components. So that is what the 7th point on the screen talks about. And there is a note also below which says the SGA size is not dependent on the database size, but it will be calculated based on the number of transactions that are hitting the database. So for example, this is one of the peculiar questions you will be getting in from interviews. So they will ask you if the database size is 1 terabyte, how much SGA I should allocate. So by this note, you need to understand that maybe your database size is 1 terabyte, but only if daily 100 connections are there in the database, then I don't require much SGA. Or suppose I have a database with a size of 100 GB, but daily 1000 users are connecting, then definitely for that I require more SGA. So the SGA size is totally dependent on the number of users connecting, but it doesn't depend on the database size. So that is what the note basically saying. And below you have a table which is representing how the parameters are being transferred from version to version. So if you look at the first one in 8i, the first 4 parameters you need to define for PGA, the next 5 parameters you need to define for SGA. And when it comes to 9i, whatever the 4 parameters for PGA are there, so those were replaced with a single parameter, and the other parameters carry forwarded as it is. The SGA parameters carry forwarded as it is. And when it comes to 10G, so PGA parameter remains same, but SGA parameter, instead of setting individually, we are now using SGA target. And when you go for 11G, you can see the diagram. PGA and SGA both are combined into a single component, that is memory underscore target. So that means in 11G, you don't require to fight between PGA and SGA allocation. Simply give how much you want to give for Oracle, and Oracle will take care of the internal memory allocation. So suppose like I want to allocate 800 MB for Oracle, so I need to just specify memory target equals to 800, then Oracle will take care out of 800 how much it need to give to SGA and how much it need to give to PGA. But as I said, log buffer is still static parameter, so that's the reason in 11G also you need to declare it separately. So basically, ASMM is the concept of making the memory adjustments automatically without any DBA intervention. So is this points clear, or anyone is having any doubt, please let me know. Yes, Sanjay, we will be seeing the practicals, but not at this moment of time, because we need to understand how to do Oracle installation, all those things. So at that time, definitely I will show you. And also, I don't have the database handy today, so somehow I could not able to connect to the server in the institute. So uh, probably tomorrow we will see the installation, so I can show you tomorrow. So any others, any queries? Okay, so let us move to the next concept. Uh, yes, we need to use for both SGA and PGA. and if it is 11G, we don't require to use it separately for SGA and PGA. Yeah, you are right. There are two parameters. One is for PGA separately and one is for SGA separately. So if it is a 10G database, definitely we require separate commands. But if it is 11G, we don't require it. Why? Because that memory target parameter will take care of both SGA and PGA. Of course, regarding that memory target, we will be learning more a lot. So we will see that. So any other questions? Okay, so let us go for the next topic, that is alert log and other trace files. So basically alert log is the one which is going to give us Oracle error information. So that is the main purpose of having alert log. Like whenever your database is hitting with some errors, then definitely we need to know, as a DBA we need to know why that error occurred and what could be the reason, and based on that we need to diagnose. So for that purpose we have this alert log, and so that is what the first point talks about. Alert log is basically a monitoring file, and using the information of alert log we are going to diagnose why that error occurred and what is the solution that we need to apply in order to avoid that error. So we'll be dealing with all those things. And apart from recording alert log information, apart from recording error information, alert log will also store some other information, like it is going to store, like whenever the database is starting up, it will record that information. Whenever the database is shut down, then also it will record that information. So it will do all those activities. And then we have non-default parameters. So most of the times what happens is, whenever you create database, Oracle will come with some default values, or Oracle will allocate some values as default to the parameters. For example, for the SGA size, it will take 40% of the RAM size, or for PJ it will take some other value, etc. So now when let's suppose I am taking an example. For the SGA size, when you are creating a database, it has taken 40% of the RAM size. Let's say your RAM size is 1 GB, and while creating the database, it has taken 40%, that is 400 MB for SGA. Suppose you change this 400 to 500 or some value like that, then this parameter will become non-default parameter. So because you changed the default value, that parameter from that moment onwards will become non-default parameter. So all those kind of non-default parameters also will be listed in alert log file. And then whenever your database is enabled in archelog mode, archeologs will be generated. So those archeologs will be those archelog generation information also will be recorded in alert log. And optionally you can also choose checkpoint information to be recorded. So but usually that is not default. That is only when we have some parameter to be set. So the main thing with the alert log file is, alert log file always will give the error message in brief. So suppose an error occurred due to some reason and database was shut down. So when you open alert log file, it will say that database was shut down because of so and so error. So it will not give more than those details. So only one line or two lines will be written in alert log saying database was shut down because of so and so error. For more details, see this file. So it will point us to one file, and those files we call it as trace files. So alert log will only give the information in brief, but the actual information or the detailed information you can see in trace files. So these trace files, based on the type of error, they were divided into three types. The first one being the background trace files. So second one is code trace files, and the third one is user trace files. So background trace files are something like whenever background process fails. We have so many background processes. We saw them like SPON, PMON, etc. So whenever this background process fails to work, then Oracle will generate one trace file, and those kind of trace files we call it as background trace file. Similar way, when operating system is hit with some errors, then it will generate some trace files, and we call them as code trace files. And whenever user got some errors, and that will also generate some trace files, and we call that as user trace files. And you can see over there uh, background trace files or code trace files or user trace files, all of them are stored in a location. So something like Oracle underscore home slash admin slash SID. So SID is nothing but the instance name, and then VDump location. So if it is a code trace file, it will be stored in CDump location, and if it is a user trace file, it will be stored in UDump location. And I hope we discussed about this point, what is mean Oracle home. So the location where you are installing Oracle software, we call that as Oracle home. So under that, all these files will be stored. Even the alert log file also will be stored in Oracle home BDump location. So those are the default destinations for the files. But if you feel that I don't want to maintain the files in this BDump, CDump or UDump locations, or you want to define your own location, then we can set these three parameters in the parameter file or SP file. So background the underscore dump underscore test, then code dump test, and then user dump test. So these three parameters you can set to a different location if at all you want to change the file generation location. But these above three parameters or the above three locations, UDump, CDump and BDump, so all are combined together into a single location in 10G, in 11G, with the help of a parameter called diagnostic underscore test. So that means in 11G, all the files will be stored in the same location. So there are no three locations from 11G above, there is only one location. And also 11G contains two versions of alert log file. One file will be stored in text format, and the other other file will be stored in XML format. So that means you can actually view that through a browser. So that is one advantage we have in 11G. So basically, as I said, alert log is for diagnosing the errors and resolving them, and supporting to the error message we will be having the trace files in place. So more about practically we will be seeing all these files tomorrow when we start the installation and database creation. So is these points clear, or anybody is having any idea, just let me know. Okay. Trace files means, as I said, whenever I hope you know the meaning of tracing. So tracing means monitoring something. So what happens in the database is, whenever some error occur in the database, Oracle automatically monitors the activity, and that means it will trace the activity, and all this activity will be recorded into a file, because as a DBA we need to know why that error occurred and all. So the complete information need to be recorded into a file. So Oracle will do that automatically for us. We don't require to do it on our own. So, and these files we usually call it, because it is tracing the event, we call them as trace files. So an example I can give, like for example, database is shut down and you want to know the reason. So in alert log it will only show you that database was shut down on so and so time due to so and so error. But what is this error, why it occurred, at what time it occurred, all that information will be recorded into a trace file. So I can say trace file is a supporting file to alert log. So no problem, welcome always. Any other queries from anyone? Okay. So let us go for the next topic then, which is optimal flexible architecture. So before going for optimal flexible architecture, I just want to show, I'm not sure how many of you know how hard disk will look like internally. So I just want to show how a hard disk will look like and all. So, so I hope everybody can able to see my screen, isn't it? So this is how your hard disk will look like when you open, the top cabin. So basically, it is a combination of cylinders or circular cylinders, I say, and there is a pointer which will always be there on these cylinders, and these cylinders basically rotates. So whenever you are going to, write something or read something, basically the pointer what you are seeing here, uh, let me show you that. So whatever the pointer you are seeing here, so this pointer basically, keeps on pushing the data or reading the data from the disk, and this cylinder portion will always keep on rotating. So that's how hard disk will work. More of a kind, I can compare this with a gramophone. I hope everybody might have have watched a gramophone at least in movies. So, and you can see on a gramophone there will be a pointer, and until unless you place that pointer, whatever the, even though the gramophone is rotating, the record on the gramophone is rotating, you can't able to hear anything until unless that pointer is placed over there. So similarly, you have the concept here, and this pointer, whatever we saw, we call it as IO header, or some people will also call it as disk spindler. So one name that was given is disk spindler, the other name is IO header. Just give me a moment, guys. I am getting a phone call. Yeah, sorry, I just got a call. Yeah, so this is what I am talking about the hard disk. So this pointer we call it as IO header, or otherwise we are going to call it as disk spin length. So the more active word is IO header. So we in DML processing we are discussing a point that database writer will write the dirty blocks to the data files, or log writer will write the data from redo log files to a log buffer cache to redo log files. So we are learning about those points. But frankly, either DB writer or log writer or any other thing is going to write only through this IO header. So, and unfortunately for a hard disk there will be only one IO header. So that is the problem here. So if you have, because you have only one IO header and multiple, at the same time, let's say DB writer asks you to write into data files, and log writer asks you to write into redo log files, and archiver asks you to generate archives. So suppose all these three background process ask you to do the work for the same IO header, then that IO header will take burden on the, that IO header will be burden, and definitely IO header cannot do all the three tasks at the same time. So it can do only one task at a time. So when it is working for DB writer or when it is working for log writer, DB writer should wait, and when it is working for DB writer, archiver should wait. So there could be some waiting period involved. So all this problem occurred because one hard disk will have only one IO header. Now, with the concept of this optimal flexible architecture, what Oracle suggests to us is to maintain multiple hard disks instead of one hard disk. So, as you can see in the points over there, in the third point it says, as per OFA, Oracle recommends to store all the physical files separately in different hard drives. That means you should have data files in a separate hard disk, you should have redo log files in a separate hard disk, you should have control files in a separate hard disk, and you should have archives in a separate hard disk. So when you have this kind of architecture implemented, because now you spread all the files across multiple disks, each disk will have its own IO header, and that will increase the performance because all the background process can work parallelly, or all the IO headers can work parallelly, thereby it will be increasing the performance. And definitely, this solution is a cost investment because you need to purchase new hard disks, so that involves cost. You need to put some extra money. But even though you are putting some extra money, you will be getting maximum performance benefit out of it. So that's the reason it's always better to implement this. And fifth point is a suggestion which says, if at all you cannot purchase so many hard disks, so at least what you can do is you can combine redo log files and control files, but data files should never be combined with any of the other files. So data files always should be having a separate disk, so that should never be combined with any other file. So this is what basically optimal flexible architecture says. So just to separate the files across multiple hard disks, so thereby improving the performance. So is this points clear? Okay, so then let us go for the next topic, that is database operating modes. So in this we are going to see how to start the database and how to shut down the database. So basically database startup contains of three phases. One is no mount, the second one is mount, and the third one is open. As you can see in the diagram, these three phases will come one by one. First no mount will be there, then mount will be there, then open will be there. So for normally the database, if it is in closed state, that means your database is down. The first phase that you are going to travel is no mount, and to travel to no mount phase, the file which is required is SP file and P file, as you can see here. And what happens in no mount phase is it is going to start your instance. So starting of the instance is nothing but allocating the memory from RAM, and also it will start the background process, all the smon, pmon, db data, log data. So all these background process will start when you start the in no mount phase, or when you start the instance. And after no mount you have a mount phase. So to go from no mount to mount, you require control files to be there. So if control files are not existing in the location, then it is not possible to go to mount phase. But otherwise, once you go to mount phase, what basically this mount phase is for maintenance. So there are so many maintenance activities we will be performing in mount phase. So as and when we see practicals, you will come to know those things. So what kind of maintenance activities we do. And when you want to go from mount to open, you require data files and redo log files. And in open phase, it is nothing but it is available, the database is available for the user access. So any user can connect then, and they can start the transaction or they can start issuing the transactions and all. So that's what basically three phases we have during startup. And commands related to startup, either you can go through a single command called startup. So this command will go through each and every phase automatically. But no, if you want to go phase by phase, you can put down the other three commands which you are seeing on the right hand side. So the first one is startup no mount. This will make the database to go to no mount state. Then you say alter database mount. This will go to mount state, and finally alter database open, which will go to open state. And there is a note here which says a database can be restarted without issuing the shutdown command using startup course. Suppose your database is up and running and you don't want to use any shutdown command, means you don't want to shut down the database, but still you want to restart the database. In such case, we will be going for the startup course command. So that is the note says. Then we have shutdown types. So when I say shutdown type, you can use any of the command in order to shut down the database. So you can use either shutdown normal, or shutdown transactional, or shutdown immediate, or shutdown abort. But each and every mode of shutdown is having some tasks involved. So we need to understand about that. So all these are represented in a diagram as you can see here. For example, if you go for shutdown normal, the moment DBA issues shutdown normal, then new users will not be able to connect. So if at all any user is trying to connect to the database after the DBA issues shutdown normal command, then that user will get an error message stating that the database is in shutdown progress. But the other point is, will the current transactions by the existing users complete? So I will come to the second column later. I am jumping to the third column. Will the current transaction by the existing users completes? And the tick mark here says it is yes. That means by the time DBA issues shutdown normal command, let's assume one user is doing some update operation. So what happens is Oracle will wait till that update operation completes. So even though the update operation may take 1 hour or 2 hours of time, till that 1 or 2 hours of time, shutdown of database will be waiting. So that is what this says. And not only that, if any existing users are there, they can also issue new transactions. So after DB issues shutdown normal command, if any existing user want to issue new transactions, even that is also possible as per the tick mark here what it says. So that means until the basic point here is until unless voluntarily the user disconnects from the database, you cannot able to shut down the database. So that is the point here. But as a DB, if you want to shut down the database, why we need to wait for other users, or why we want to wait for users for so many hours to shut down the database? So it will be no reason. So that's the reason in real time we will never use this option. We never use shutdown normal. And then going to shutdown transactional. Here also the first column is same. So once a DB issues shutdown transactional command, new users will not be able to connect, but the existing transaction completes, like what it is mentioned in third column. But the advantage is existing users cannot issue new transactions. So that is what the into mark says here. So you cannot issue any, or the existing users cannot issue any new transactions. So that is one advantage we have. But still this will also give some problem. For example, by the time DB issues the shutdown transactional command, let's say a user is executing a long running DML statement. So and it runs for the next 5 hours. That means even though you are using shutdown transactional, your database will not shut down for the next 5 hours. So which is very ridiculous. So that's the reason even this option also we can't use in real time. And then we have the third option, that is shutdown immediate, in which case you can see new users will not be able to connect, even existing users cannot issue new transactions, and even the current transactions also will not be complete. So if any transaction was already running, even that transaction will be stopped there, and that will be rolled back. So what Oracle will do when you issue shut immediate, if any transaction is running, it will stop the transaction there and it will do a rollback. And immediately our database will go for shutdown. So this is the advantage that we have with shut immediate. And because we are not waiting for anything here, we can use this option in real time, and this is what we use in real time. So in real time we will never issue shutdown normal or shutdown transactional, we will go with shutdown immediate. And when you look at the fourth column, in all the first 3 cases, checkpoint event will occur. So we know already what is meant by checkpoint event. Whatever the dirty blocks that are that are generated in the write list, so those dirty blocks should be made permanent to the data files. That means DB letter should write them to data files. So in all the first 3 cases, checkpoint event will occur. But in the last option, that is shut abort, it is this checkpoint event will not occur. And because checkpoint event will not occur, this is exactly equals to your instance crash. And whenever you issue shut abort, it will be like instance crash. And whenever you are starting up the database next time, S1 will come into picture and it will do the instance recovery. So that is the reason usually we don't prefer to use shutdown abort in real time. So in real time always we follow with shutdown immediate. So is this points clear, or anyone is having queries, please let me know. In real time, we will never use startup force. So that is just an option we have, but we will never use it. Yes, definitely when we are changing a parameter, when we are changing a static parameter, we require a shutdown of the database. So definitely we will be using shutdown immediate. Always, not not shutdown normal and shutdown transactional. We will never use them in real time. Always we will go with shutdown immediate. That's it. We don't have any other option for it. If a parameter is defined as static by Oracle, definitely you need to go for shutdown. So even it is a 24 bar 7 running database, it's not possible. So without that it is not possible. And moreover, changing the value of a static parameter will be a one-time activity. So even what Oracle has did is, whatever the parameters which will be changed only once are defined as static parameters. Whichever the parameters you would be changing frequently, those were made as dynamic parameters. So that's the reason setting these values for static parameters will be a one-time activity. So that's the reason you may not see that much impact. So even though we say 24 bar 7 databases, frankly saying, for them also there will be some downtime. So no database will run continuously for 24 bar 7. So why? Because we have a concept called patching. So if you want to apply a patch, then also you require then also you require database to be down, or when you want to upgrade the database, you want a downtime. So you can't really avoid it. So there are some situations where you need to definitely handle the things. So let us jump into the next concept, that is shared server architecture. Now in the architecture, whatever we saw till now, yeah, after shutdown immediate, we will be using this command, startup command, in order to start the database. Either this command or these three commands. You can use any one, and you can start your database. It's not alter database commands. Anyway, we will be seeing all of them in practicals, so don't worry about it. Okay, so any more queries? Okay, so coming to shared server architecture, whatever the architectures we saw till now, So that is a dedicated server architecture we say. Why? Because for every user process there will be a separate server process. So if 100 users are there, there will be 100 server processes. But what happens when more and more users keep on connecting is whatever the PGA size you have defined, that will be cutting short. For example, let's say I have allocated 200 MB to PGA and initially 10 users got connected. So in the beginning of the class I said when 10 users connected, this 200 MB will be shared across 10 users. So that means each user will get 20 MB. Now let's say after some time these 10 users have become 100 users. So that means 200 MB by 100 users. That means each user will get only 2 MB. And after some time, let's assume that number of users count is increased to 1000. That means 200 by 1000. Each user will get only 0.2 MB of PGA. Or if this user count is still increasing, and the memory size will keep on decreasing. So when this memory is keep on decreasing, at one moment of time Oracle will throw some errors in the database that it cannot allocate any memory to the server process, or it cannot allocate any memory to PGA. So Oracle will throw such kind of error. So to avoid that error, we have this shared server architecture in place. So in shared server architecture, what happens is instead of one user process having a dedicated server process, we will be having multiple shared server process supporting multiple user process. So you can see the diagram over here. So in the diagram there are three circles which represents three shared server process and multiple user process which you see above, UP1, UP2 and UP3. So all these processes will be connecting to the database or will be connecting through this shared server process. So how the processing will be done is there is an extra component here called dispatcher. So dispatcher is again divided into two components. One is the request queue and the other one is response queue. So what happens in shared server architecture is, suppose user process 1, user process 2 and 3 are connected to the dispatcher. So user process 1 will send its statement, whatever it could be. It could be a select statement, DML or DDL. So that statement will be placed in request queue. Similarly, the statement for user process 2 and user process 3 also will be placed into request queue. And from request queue, this shared server process will take the statements and it will send them to library cache. So from there everything is exactly same. So if it is a select statement, you know how it will process. If it is DML or DDL, you know how it will process. And finally, once the statement got processed, the result will be again placed into response queue of dispatcher, and from there the response will be given to the user process. So what basically dispatcher is doing here is it is accepting the statements and it is sending the response. It is accepting the statements and it is sending the result to the user process. So that is what dispatcher is going to do. And as you can see, one dispatcher can handle multiple user processes here, and one shared server process also can handle multiple requests from the dispatcher. So that is how basically the things are going to work. So now the interesting point here is, earlier for every server process we have a dedicated memory, which we call it as PGA. So we know that parsing will take place in library cache, then execution will take place in PGA. But to execute the statement in PGA, here in the shared server architecture, PGA concept itself is not there. So you can see here there is no PGA written here. So then how execution will take place? So instead of PGA, Oracle has declared a new memory component called UGA, stands for User Global Area. So, and this is a shared area. That means even now the execution will be shared with all the other users. So you are giving a common area and every statement should get executed here. You don't have a separate PGA for server process. So this will automatically reduce the burden of having multiple PGAs and thereby improving thereby handling the situation. So without getting any error, you can run the shared server architecture. But one point we need to understand is shared server architecture is a temporary solution. So if at all your PGA memory is not sufficient, then increasing the RAM size is the permanent solution. But to increase the RAM size, you may need some time or you may need some approvals, etc. etc. So in the meanwhile, you can enable this shared server architecture and it can help you as a temporary solution. So shared server architecture is not a permanent solution, it is a temporary solution. And the points in the next pages talks about all these things, how it is going to work and all. And sixth point here, what you are seeing on the screen is important. You can see there, this architecture, that means shared server architecture, should be enabled only if aura 04030 or 04031 errors are observed frequently in the alert log file. So those two are the error numbers. Whenever memory is not sufficient, Oracle will throw that errors in the alert log file. So if daily you are observing these errors in the alert log file, then you need to go and enable the shared server architecture. So, and as I said earlier, shared server architecture is a temporary solution. The permanent solution will be always to increase the RAM size. And you can see here, a single dispatcher can handle 20 user requests, whereas a single shared server process can handle 16 requests. So even similarly, we have SMON and then DB-rater. So in the architecture, if you see, SMON and DB-rater will have a suffix n. So what is this suffix n says is, you are going to have multiple processes or multiple slave processes for them. So SMON can have 16 slave process and DB-rater can have 20 slave process working concurrently. So when you have multiple slave process, the operation will be faster or the activity will be parallel and faster, and that thereby improving the performance of the database. And there is another note which says startup and shutdown is not possible if you connect through a shared server connection. So practically when we discuss about networking with Oracle, I will show you this point. So as of now you can just read and ignore. Practically I will show it at a later point of time. So we have a query from Raghu. Yes, Raghu, even in real time we will be using a dedicated server only, because dedicated server is having its own advantages like the private global area. So it is having its own PGA, so all those kind of advantages. So even for the databases with thousands of connections, still you will be going for that facility only. So having shared server architecture is a very rare case. And one more thing is, you can have both the shared server architecture and dedicated architecture in the same database. So actually, when you are enabling shared server architecture, it doesn't mean that you are switching off the dedicated architecture. So when you are enabling shared server architecture, you can make something like some connections to use dedicated architecture and some connections to use shared server architecture. So you can define that in something called tnsnames.ara file. So in the seventh point that is mentioned here. So you can see on my screen. So to make shared server architecture effective, server equal to shared should be mentioned in client tnsnames.ara file. So more we will understand about this when we saw networking with Oracle. So till that time, just wait. So at that time we will be discussing more. It is not every server that can be used as shared. It is every server process that can be used as shared. So server means physical machine. So physical machine we are not sharing it. We are talking about server process. Earlier we used to have one server process for one user process. Now we will be having one server process serving multiple user process. So any more queries from anyone? Okay, so let us stop the class today at this moment. And tomorrow, first we will be talking about 11G database architecture. There is a little bit different, or I can say a new component got introduced. So we will see about that. And along with that, we will be looking into installation of Oracle 10G database and 11G database on Windows platform. So first I just want to show you on how to do that on Windows, and then we will proceed on Linux. So we will be looking into all those details tomorrow. So anybody is having any more queries? Okay. So then let us meet tomorrow at the same time. And thank you everyone for joining the session. And Devendra, already daily I am uploading, and I hope you people are getting those links. Initially I have shared the link for the recorded videos. So have you got that email? Okay, fine, just a minute. Let me... Okay, even though you are not getting any link, first day when I shared it, you might have got the link. So the same link you can use it daily. So you can see all these are videos that I have uploaded. So till yesterday I have uploaded all the videos, and even this is shared with you people also. Now So here you can see it was shared to you also, Devendra. You can see your email ID here. So just verify whether you got this link or not. So maybe that email went to spam or something. So you can just check over there. So all you people are having the option. Okay, so just check those things. Okay. So let us meet tomorrow at the same time, and we will discuss about the other things. So thank you very much everyone for joining the session, and have a nice time till then. Bye and good night.